Hello and welcome to my channel. So today we will be discussing a problem in linear algebra. So and for the previous problem and other problems you can visit the website. The link is also provided in the description of the video. Okay, so today the problem is about the eigenvalues and the properties of the eigenvalues. The problem is, let A be a 2 cross 2 real matrix with determinant of A is equals to 2 and trace of A equals to 3. Then what is the value of trace of A square? Okay, so we are given with determinant, trace, and we need to find out what is the value of trace of A square. Okay, so I recommend you to pause the video and try the solution on your own, and then again you can watch the solution. Okay, so I hope you tried the solution. So let's see how this problem is related to the eigenvalues. So we need to find the trace of A square. So see, if lambda 1 and lambda 2 are the eigenvalues of A, then what we have is that sum of the eigenvalues is equal to the trace of A, and this is true always. So sum of the eigenvalues is equals to trace. So this is not restricted to 2 cross 2 matrix. It is true for any n cross n matrices. This is the sum of all the eigenvalues equals to the trace. The next is that product is equals to the determinant. So this is also true for any matrix, that product equals to the determinant. That means product of all the eigenvalues is same as the determinant of that matrix. Okay. And now the third thing is, if lambda 1 and lambda 2 are the eigenvalues of A, then eigenvalues of A square is lambda 1 square, lambda 2 square. Okay, so in general, if lambda is an eigenvalue of A, then lambda square is an eigenvalue of A square. Okay, okay, and this is not hard to see. It's like you have AV equals to lambda V. V is an eigenvector. And what is A square V? Okay, I can see A square V is A times AV. Now I can write AV as lambda V. So it's like lambda V. And then again, lambda I can take out, then again AV, which equals to lambda square V. Okay, so you see that the eigenvalue is getting squared, but the eigenvector remains same. Okay, so using this property, we can solve this problem. So if you were not able to solve the problem before, just pause the video and try to use this property and solve the problem. Okay, so let's see. So using this fact, what we have, like in the problem, you see that in the problem, the trace equals to 3 and determinant equals to 2. Okay, so lambda 1 plus lambda 2, which is equals to the trace, which is equals to 3, and lambda 1 times lambda 2, which is equals to the determinant, which is given 1. Okay, and hence what is the eigen, what we need to find out? The trace of A square. So what is the trace of A square? Trace of A square is lambda 1 square plus lambda 2 square. So this is what we need to find out. Fine. Okay, so see that lambda 1 plus lambda 2 square is equals to lambda 1 square plus lambda 2 square plus 2 times lambda 1 lambda 2. Now we know what is the value of this. This is 3. What is the value of this? This is 1. Can we find out the value of this? Yes. So from this, lambda 1 square plus lambda 2 square is equals to 3 square minus 2 times 1, which is equals to 9 minus 2, which is equals to 7. And hence, what is the value of trace of a square? It is equals to 7. So just recall today that what we did, two important properties is that sum of eigenvalues is equals to the trace, and this is a very important property of the matrix, and product of the eigenvalue is equals to the determinant, and if lambda is an eigenvalue of A, then lambda square is an eigenvalue of A square, and the eigenvector remains same. Okay, so these three properties are important for any exam, NET, GATE. Okay, so I hope you enjoyed the video. In case, please like it, subscribe, and share with your friends. Thank you. We'll meet again tomorrow for a new problem in real analysis. Goodbye. Take care.